Thank you. It's fantastic to be back in Paris. So 22 years ago, in May, I did 10 days of hard work. I didn't sleep much. But before that, in February, I was recruited. My friends said, you know, come out to the coast, we'll have a few laughs, do Scheme in the browser. And by the time I got there, of course, it was supposed to look like Java, and as Christoph said, be a little language. I knew after I got into Netscape 2 that it would either die quickly and Microsoft would completely replace it, or it would be around for 20 years or longer. And I said this to my cubicle mate at Netscape, Jeff Weinstein, so he can testify to that. But people get impatient, and they get tempted by things like, you know, Windows on the PC, and you think the web will die every 10 years, and it doesn't. It just keeps going. And that's why I like this quote from Ian Hickson, things that are impossible just take longer. I'm going to cover why that is necessarily so with the web and the best way to cope with that fact. I've been around a long time, so there was Netscape, JavaScript. I founded Mozilla with Jamie Zawinski and other people. Did Firefox, which restarted the browser market. Nobody thought that was possible. Taught Google how to do Chrome. And for me, the interesting innovation is now going into peer-to-peer networks that are not just for downloading songs, but now for things like cryptocurrencies. And involved in those, as well as in ad blocking, tracking protection, and privacy by design. I think privacy tech is going to be big in the next 10 years. I'm glad that Europe is doing its part there. How do we cope with the fact that in any regime of web browsers, you're going to have competition? You might have a near-death experience where Internet Explorer takes 95% of the market, but Firefox showed how to restart it, and I think that will be a lesson that is not forgotten. That means you'll have competing browsers working in standards bodies, and they have to find a modus vivendi. They have to get along, and the best way that I've learned to do it is just not smoke, but to socialize. And this has been going on with JavaScript since 1996, November, when Netscape took JavaScript to the ECMA standards body. At that time, it was the European Computer Manufacturers Association. Here's the Secretary General of the time, Bon Vivant, I remember fondly. He's retired now. He lived in Geneva. He has a Dutch surname, but he's Belgian-born, polymath, raconteur, really fun guy. And that, I think, taught me something that we've tried to keep going in this committee, that you have dinners together, and you try not to hold grudges or let personality conflicts, which are inevitable, get the better of you. And Netscape, while it lasted, did that. And Microsoft even played relatively fair as they took the browser market. But then they shut it all down. So with Firefox, we brought it back, and we actually restarted it. I went to Geneva in 2005, after Firefox 1.0 came out in November of 2004, and I said to Jan, let's bring the band back together. It's time to improve JavaScript again. And you know, Microsoft was kind of like, oh, do we really have to? We're doing C#. But Macromedia had used a version of JavaScript called ActionScript in the Flash player, and so we formed an alliance with them. And this led to a bunch of learning and socializing and philosophizing that I think is important. I use this famous painting by Raphael. There's a detail from it. That's Doug Crockford on the left and me on the right. Doug's always pointing up, and I'm like, keep it real. There are bad problems in committees. It's inevitable because you get conflicts of personality and conflicts of style and sort of deeply held beliefs that aren't fully unpacked into chains of reasoning. It's hard to reason together if people come from really different schools of thought. So we've learned how to cope with this by not rushing to any conclusion. When you're doing language design, you're solving many problems which cross-cut or trade off against each other. You have to take the hermeneutic spiral, as it's called. You have to be willing to go around several times before you close on a design. And sometimes you have to throw things out and start over again. That's happened, for instance, with ES6 proxies. You have to avoid the temptation to say, well, I have developers that are solving this complex compound problem, so I'm just going to give them a complex compound solution that's kind of a fixed composite function, because that usually doesn't work. It's usually the case that when you decompose it, you find that you've got uncomposable parts. And what we'd rather do is what the scheme in the browser, the scheme report says in its very first paragraph. It says, break the language down into orthogonal primitives that work well together. So that's been the job of the committee, and coming to an understanding of those primitives and minimizing the choice of primitives, choice of axioms has been important. Then there's the ugly. I shouldn't linger on it. TUCO. You find people sometimes let their competitive interests get the better of them, and so they use essentially bad faith arguing. They find sort of vague excuses for not doing something, and they all have some truth in them. They're all half-truths. You ain't going to need it. Don't scare the junior people. Don't make it into Java. But you have to actually get into the concrete aspects to get past those objections, because that could be true of many things that we want. And while we don't want to make JavaScript into Java, languages grow. There's a great talk by Guy Steele where he starts with a subset of the English language in presenting the talk, and then he grows his subset as he gives the talk. Languages grow. That's how they progress. So we've had to cope with the good, the bad, and the ugly, and we've made progress. The old days were when Netscape had some market power, which was going away, and we got ES1 done, based on my work in Netscape 2 and 3. ECMAScript 2, just historical curiosity, was the ISO version of ES1. ES3 was the big one. It had a bunch of new things. It had fully nested functions and closures, function expressions. A lot of you may have heard about ES4. I spent many years on that. That's where we, with Macromedia, which got bought by Adobe, tried to really get Microsoft to sit up and pay attention by doing the big language that had been envisioned even in 1999 by somebody named Waldemar Horwath of Netscape, who I gave the keys to the kingdom to. And he designed this language. ActionScript 3 has a lot of aspects of it. It actually got implemented by Microsoft on the server side in 2000, but they never promoted it and did not standardize it. ES4 failed, but the failure was important because the committee then, with my codename Harmony, found a way to come together and work on ES5, which was the no new syntax, 3.1 kind of incremental step from ES3 that had been started concurrently with ES4. Doug Crockford and others dissenting from ES4 in public. We pulled everybody together, and we've been operating in a much better mode since then. ES6 obviously is a big leap forward. A lot of backlog had to be absorbed. But now we've got onto a better cadence. There's a backstory. Some of this is, you've heard about scheme in the browser. It was a lie. It was a vain hope, let's say. There were other things that I did in a hurry in the 90s that I do regret. Do while, switch, try catch, that's all okay. I think that worked out. Regular expressions, faute de mieux, I based on Perl 4. Sorry. I met Larry Wall in 97, and I said, hey, I'm putting Perl regular expressions in JavaScript, and he turned green. He looked very unhappy. He was changing them for Perl 5. And Perl 6 is even different because he could do a clean slate language. The restarting of TC39 I mentioned, that was painful because Microsoft didn't want to do much to the language until they did. And when they did, it was still this sort of half-hearted thing until I think Chrome came out, and that really woke them up. So we had amazing performance work in JavaScript engines. We even had Google say that JavaScript cannot be repaired, so we'll do Dash, now Dart. And I told them it wouldn't work. They didn't listen. That actually leaked through an accidental global message post by somebody on the TC39 committee whose name is on it. He's not the author of that Dash memo, but he turned white and went over to another Googler during the November 2010 meeting and tapped them on the shoulder in a theatrical fashion. And all the Googlers decamped to the hall, and we said, what's going on? Has the singularity arrived? Has Sergey or Larry canceled free cookies? Only later did we learn that my friend on the committee from Google had accidentally posted this internal memo, which said JavaScript must be replaced. It was like, we love JavaScript, but it must be replaced. And it's just really hard to replace. There's something like successful DNA about JavaScript. Once it's in there, you're going to have a hard time getting rid of it. Another thing I'm particularly proud of in the last 10 years was this sort of discovery, carving nature at the joint, as Plato said, of science, of ASM.js inside of JavaScript. If you look at C code, and some of you probably know C code, you have a statically typed language with machine types. And there is fast C code, notably games. Games are always torturing the hardware. can you map that to JavaScript? It turns out you can, and this was discovered first, I think, by Alon Zakai, maybe by others concurrently or a little bit before at Adobe Labs. And the trick is to use the bitwise operators that I put in. Most of them come from C, one of them comes from Java. So I'm really glad I put those like vertical bar operator in, because that, if it hadn't been in there from 1995, it would have been hard to add later. And the fact that it was there all along meant we could do incredibly fast JavaScript. Also needed typed arrays from WebGL. And this is not meant for reading, but just the dynamic nature of JavaScript has led to a common architecture in I think all the top engines now, the open source engines, where you have interpreting and you have sort of a fast just-in-time compiler, a baseline compiler, and then you have a much more aggressive compiler that operates when there's really hot code running. And the fast subset of JavaScript that is ASM.js, the statically typed fast subset, allows bypassing the baseline JIT and the interpreter, which has paved the way for WebAssembly, which we're all excited about. A little more backstory. I realized after Alan Wurst-Brock did a great job as editor of ECMA 262, and as we got ES5 done, that he was not happy at Microsoft. So I recruited him to Mozilla, and we did ES6. That was a coup, and I was glad to have Alan on the crew at Mozilla there. The formalization of ASM.js as a type system was by Dave Herman. The exploratory compiler-driven work was by Alon Zakai, and Luke Wagner did the amazing compiler that bypasses those JITs and does a sort of whole module compilation to machine code. And it all came together in one week in the fall of 2012 in Raleigh, North Carolina, at Epic Games. Unreal Engine 3 was ported in 4 days. You know, you had to get the audio working using OpenEL mapped to WebAudio. You had to get OpenGL mapped to WebGL, fix a few compiler bugs, and suddenly this game is running at 60 frames a second. Tim Sweeney, the founder of Epic, said he thought it would take years to get there. I think this pretty much killed portable native client and other such approaches. It was, at that point, inevitable that WebAssembly would emerge. Babel.js was interesting because 10 or 20 years ago, people would say, I'm never writing code with a compiler. I'm writing JavaScript to the metal. And now they've gotten used to using tools, and I think that's beneficial. Linting, but even type systems, TypeScript, and so on. And at some point, I think the committee will standardize some kind of type system. We have a new proposal from some folks at Google. It's going to take a while. There's disagreement between Flow and TypeScript, and there's a lot of evolution and exploration to do. You know how modern software works on a rapid release cycle, like 6-week cycle for Firefox, Chrome, Brave. Some of their browsers are more like an annual cycle. The ECMA committee is now going on an annual cadence, which is good because it gets rid of that schedule chicken problem where if people feel like they're going to miss, they can just go to the next year. They don't try to hold up everything to jam in something that doesn't fit. And as predicted, Google threw in the towel on Dart. And around the same time, I think threw in the towel on portable native client. It was not going to go cross-browser. Meanwhile, WebAssembly was out in 2015, June. So there's been a lot of interesting backstory that you may not hear everywhere. I sometimes try to share this. This is at a Brooklyn JS meetup where I said, some things change, some stay the same. Apple is still Apple. Other companies sort of trade roles and attitudes. And right after that, of course, Microsoft open sourced their chocolate core JavaScript engine. We're still waiting for Edge, but it could happen. It was a good move. I'll just share in detail one of the new things that's coming into ES 2018 or something. I don't know when it'll be. It's getting implemented in all the engines now, all the open source engines. And that's big int. You know how when you start counting up in JavaScript, you get past a 53-bit integer, you lose precision. I didn't have time to do any other number types, and I did put in those bitwise operators, so implicit in JavaScript are 32-bit signed and unsigned integers. Other than that, you're out of luck. And if you want to go to really big numbers, like the finance people do, you end up using your own big decimal or big integer library. But we're putting big int into the language. It will have nice n suffix for literal syntax. It'll have operators that work sensibly, even with some safe conversions for comparisons. It will have the ability to name property keys and cast to narrower integer types, which is important for ASM.js because big int will matter there. This is how we're going to project 64-bit types through JavaScript big-ins back into 64-bit machine types in ASM.js. I had to get this ball rolling by saying, let's do 64-bit types. And a couple of people, Dan Ehrenberg notably, said, let's do big-ins. And we can make it just as fast, and it'll be better. And Dart had big-ins, so we know it's better. So that's good. I'll put these slides up so you can see the links. Here's an example. The Fibonacci function in JavaScript, nicely using destructuring and computing Fibonacci numbers, and if you go up to fib 79, you run out of 53 bits of mantissa in IEEE double. Everyone blames me for IEEE's floating point problems, like not a number. Somebody put a tweet up with a oscilloscope with not a number. This is like a Tektronix or HP oscilloscope, and they said, it's JavaScript. And I said, no, it's not. It's C code. It's IEEE. But I'll take the blame. With big int, we get rid of this. We get the true answer in green instead of the wrong one in red. Just to show you that the committee is not messing around, these are a selection of the stage 3 proposals. Those of you who know Node realize import as a function is hard to do statically, but it's coming, thanks to Dominic Google, Dominic Danicola. So dynamic import, pretty big. Michael Ficar is championing flat map and flattening for all the functional fans out there. Seb Marpage at Facebook is doing rest and spread for objects. That's what the third line shows. We're evolving classes and actually, I think, other things to have private fields and methods. And the design is more like Ruby, I think. There's still some details being debated there, but this is at stage 3. Asynchronous iteration, so you can do for await of, and you can totally efface the pain of promises. A bunch of regular expression fixes. Look behind, back in 1997, just missed ES3. It was just being added to Perl when we were cutting off the ES3 regular expression features. So finally getting look behind assertions, and Unicode is getting help and named property groups, the /s flag on regular expressions. And there's much more small proposals, some bigger ones I didn't cover here. They all have to go through a rigorous process to get into the next version language, but in the annual cycle we're going at, JavaScript will continue to evolve, and that's why I say always bet on JS. And I have to treat WebAssembly fairly because it's another input language for the same JavaScript VM that we all enjoy in multiple browsers. And oh yeah, Webpack's pretty cool too. Thank you very much.